Okay, 12.7 in IM1 is using congruent triangles, and the main use is how to solve problems and to write proofs. So we're going to get going. So explain how you'd use the given information to prove that the hang glider parts are congruent. So again, I'm going to draw it out so you can see it a little bit better. And this is the information that they're given. Angle 1 equals angle 2. Therefore, angle Q is equal to angle S. And the reason we can say that is because 1 and Q are a linear pair, and 2 and S are linear. This angle, STSR, are a linear pair. And since they're congruent, since RQT and RST are congruent to angle, they are linear pairs to congruent angles, then they are congruent angles. Boy, I said that really poorly. So I got that. And I also have RT is equal to RT, and therefore, and therefore by angle side angle side, these sides are congruent. And since I have them, so triangle RTQ is congruent to triangle RTS. Then by CPCTC, I can say that QT is congruent to ST. Okay? By corresponding parts of congruent triangles. Alrighty. Okay, so we're going to use a congruent triangle to find some measurements. So, and this is what geologists do and people measure when they can't get to a certain point. So watch the process. To find the distance across a river from point N to point P, that's this, they're going to first place a stake at a point K. Okay, here's K. Then they're going to find the midpoint, or they're going to make sure that K and KN and NP create a perpendicular line. Then they're going to find M, which is the midpoint, okay? Then they're going to locate a point L so that LK is perpendicular to NK. So now we've got two perpendicular lines. Then they're going to say locate L. So yeah, okay. And these L, M, and P all have to be collinear. So they use these special devices to do this. Because NK is perpendicular to NP and NK is perpendicular to KL, then angle N and angle K are congruent right angles. Okay? Because M is the midpoint of NK, then NM is equal to MK. So we know that because it was the midpoint. Then we have the vertical angle KML and NMP, and we have just proven that these two triangles are congruent by angle side angle. Because they are congruent, then we know that KL is congruent to NP. And all we have to do is take the land measurement of LK, and that will give us NP. So it's a very convoluted way of doing things, but that's how you have to do it when you can't cross something. Okay, so you can read this. It's called indirect measure. Okay, so let's look at this one. Explain how to use measurements in the diagram to find the distance across the pond. So the first thing, by the vertical angle theorem, we know that these two angles are congruent. So therefore, angle AED and CEB are congruent. Because this one is congruent to this one, and DE is congruent to BE, we now can prove that these two triangles are congruent by side angle side. Okay? Then, by CPCTC, we can prove that AB is congruent to BC, or CB, and therefore BC is equal to 57 yards. Okay? So, understand how to do that. Okay, planning a proof involving pairs of triangles. Use the given information to write a plan for a proof. So we have angle 1 equals angle 2, and angle 3 equals angle 4. Now, you have to stop at this point because it looks really easy, but which triangles are they trying to prove? They want to prove that triangle BCE is congruent to DCE. So right away, they're telling me that I don't have enough information because these angles don't give it to me. So what I'm going to have to do first is I'm going to have to prove the big triangle. So I can prove these two triangles first. So CDA and CBA. I already have these angles are congruent to each other, okay? And I have this side is congruent by reflexive property. So I can prove triangle CDA is congruent to triangle CBA. Okay, so now I've got those big triangles congruent. Then I can say that CD is congruent to CB, right here, by CPCTC. Okay, so now I've got, and then I have this corresponding part, so CE is congruent to CE by reflexive property. Okay, and therefore angle BCE is congruent to triangle DCE by side angle side. And this one was by, how did I prove that? Angle side angle. Okay, so notice that I had to use this, I had to get this first in order to use this. Then I could use the small side that was actually part of the two triangles, and then I could get side angle side. So think about how you would do that for yours, okay? All right. Okay, so this is from your journal, so let's look at this. So first thing we're going to do is explain how to prove that the statement is true. So first thing I have is I have angle T is congruent to angle W. I have TV is congruent to WV. And I also have vertical angles here. So I can say that angle UVT is congruent. Make sure you use corresponding parts. XVW, notice the T and the VW, which are congruent angles, are in the same place, and the V is in the same place because that's our vertical angle vertex. And by vertical angle theorem, those were given. So now I can prove that triangle TUV is congruent to triangle, start with the matching one, WXV by angle side angle, and therefore UV is congruent to XV by CPCTC. Okay? Always remember that is your wild card to throw in when you're done with everything else. Okay, so they want you to prove that TS is congruent to VR. That's this one and this one. So right away I can see that I have two right angles. I can see my hypotenuses are congruent. So hypotenuse angle RU, not angle, sorry. That's not an angle. So the hypotenuse RS is congruent to the hypotenuse RU. Okay, and I have legs. RT is congruent to leg UV. Make sure you have the right angles in the same place because those are the corresponding parts. And therefore, triangle VUR. I can name my first triangle anything I want, but then I have to list the second one with the corresponding parts. So the T is my right angle, then I go to my vertex, so that'd be R, and then I go to S. So triangle US by HL, hypotenuse leg, because they're right triangles. And then I have TS is congruent to VR by CPCTC. Okay, and that's corresponding parts. So remember, you can't, okay, so, yep, there you go. That's not what I was going to do. Alrighty. Okay, so on this one, we got to be very careful. What are they getting us to try to prove? JLK, that's this angle here, is congruent to MLN. That's this angle here. So I can already see I have corresponding parts that are congruent. So I can say that triangle KJL is congruent to triangle, go with the corresponding parts, NM. So KJ is congruent to NM, and then the last letter is L. And those are congruent by side, angle, side. Okay? Therefore, angle JLK is congruent to angle MLN by CPCTC. Alrighty. And up here we have exercise 4 and 5. We're just going to do we might do 5 on the next page. I'm not sure. But write a plan to prove that angle 1 equals angle 2. So here's angle 2 and here is angle 1. So here's how I would do that. Okay? So I would say angle F is congruent to angle H given right angles. Okay? And I would also say that angle FGJ is congruent to angle HIG. I'm going to put all the things I know. That's also given. That's the ones that are marked. And I can say that JG is congruent to GJ by the reflexive property. Whoops, reflexive property. Okay, so now I want you to look at what we just proved, because it's really important that you understand where we're coming from. So that just proved that these two big triangles are congruent. Okay, triangle GFI is congruent to IHG, sorry, and that's this triangle is equal to this triangle, the whole thing. So triangle GFI is congruent to triangle IHG by angle, side. Okay, so now I can say that FG is congruent to HI by CPCTC. So let's change colors here so you can see what I'm doing. So FG, that's this side, is congruent to IH. Okay, and now I can say that, let's see, oh, and it was given, notice here, that IJ is congruent to JG. That was given. Okay, notice right here. And so now I'm going to prove triangle FGJ. FGJ is this one, is congruent to triangle HIJ, that's this one, by side, angle, side. Okay, by side, angle, side. These three parts over here to these three parts over here. And therefore, angle 1 is congruent to angle 2 by CPCTC. So you should always be starting with a pause here on any of these problems and trying them out yourself. Okay, let's do one more. So this is number 5. I was hoping it would be here. So we are proving that angle 1 equals angle 2. So that was written on the previous page. So prove Angle 1 is congruent to angle 2. So first we have to look at what's given. We have AB is congruent to AD. That's given. And BC is congruent to DC. So those are both given by the diagram, right? Therefore, okay, so, and we know that AC is congruent to AC by reflexive property. So triangle ACB is congruent to triangle ACD. So if you're looking at the picture, that's, I'm going to put these as dotted lines. It's these two triangles are congruent. Okay? Triangle, and that's by side, side, side. Okay. So now we can say that angle ACB, that's this angle, is congruent to ACD by CPCTC. So we're going to change color so we can show you the difference in the parts. I lost where my pen was. So we're going to go back to red. So we're going to say angle ACB is congruent to triangle ACD, angle I mean, by CPCTC. So now we've got these two equal. And we've got these sides are equal. And now we can say EC is equal to EC by reflexive property. So now we've got this little triangle, triangle CBE is congruent to triangle CDE by side angle side. Side angle side. We should have 3 lines there. So side angle side, and therefore angle 1 is congruent to angle 2 by CPCTC, because those are corresponding parts of congruent corresponding parts of congruent triangles are congruent. Okay, so there you go. All right, that's it for 12.7. Have a great day.